Alright, so finally we're going to do linear equations part 3, and we are going to talk about word problems involving constant change. Those are things that have a, if it has constant change, there's a linear relationship. Okay, and that slope is equal to that constant change. So we're going to think about slope as a rate of change, and you've heard of this before. But if you drive, okay, 600 miles in 12 hours, your average speed is 600, the distance, divided by 12, the time, miles per hour, so that would be 50 miles per hour. That's your average speed. You did that by calculating the change. Okay? What we're going to do now is when we talk about slope as a rate of change, their slope's going to have units. This is slope with units. Okay, and it's something that becomes important to us when we deal in calculus. We're talking about solving problems with slope with units, and slope is it's half of what we do in calculus involves slope, and it comes from slope. And so it's a very important idea that we're talking about. Now, let's look at this example. An office buys a new copier for $8,000. 5 years later, the copier is worth $2,500. Assume the copier depreciates linearly. At what rate is the copier decreasing in value annually? Include proper units. Write an equation for the value of the copier as a function of time. Okay, first of all, it says depreciates linearly. Depreciates linearly. Okay? Well, that means that it has a constant rate of change. And the slope of a line would be that constant rate of change. Okay, and now it says at what rate is the copier decreasing in value annually? So we assume then that when it starts out at 8,000 and 5 years later when it's worth 2,500, it's losing the same amount of value each year. And we could figure that out, but let's say we think of this as 2 points. When the copier is new, it's 0 years old, and it has 8,000, okay, is the value. When the copier is 5 years old, it is worth 2,500. Okay? And now we have 2 points, and we know that this is a line because it says linearly. So then we can find our slope. So it'd be 2,500 minus 8,000 divided by 5 minus 0. Well, that is negative 5,500 divided by 5, or negative 1,100. Now what does that mean? Well, let's remember that. Let's look back here. 2,500 and 8,000. Both of those are in dollars. The units for the top, now we have a slope formula, but now it has units in it. So the slope for the top is dollars. The unit for the top. The unit for the bottom, it says, is in years. So this is dollars per year. So it's a slope with units. That would be the units. Okay. Now we want to write an equation for the value of the copier as a function of time. So we could write it one of 2 ways. The easiest, quickest way in this case is y equals mx plus b. Because we have our slope, so y equals negative 1,100x. We also have our y-intercept, because remember, our y-intercept is always when the x value is 0. So it'll be negative plus 8,000. That would be an equation. You could do point slope form with either point, and that would be fine. Okay, that would be fine. You could write y equals, 2,500 plus negative 1,100x times, negative 100 times x minus 5, and that would be fine. That would be fine. Okay, so you're going to get the same thing actually in the long run. The equations are the same. So I would accept either one of these as your equation. All right. Example 9. The startup company made $15 million in 2014 and $22 million in 2016. Assuming the relationship between year and profit is linear, write an equation relating the two and predict the company's profit in 2017. Okay, so again, it says it's linear, which we're looking for then a couple things. We're looking to see if there's a couple points. We're looking for information that can help us write the linear equation. And that could be a couple points that are on the curve, okay, or it could also be they tell us a rate of change. Okay. So I have 2 points. The first one is 2014 and 15 million. And then 2016 and 22 million. So again, this problem now has just become exactly like the last one. So my slope would be 22 minus 15, okay, and then it would be 2016 minus 2014, and this is millions of dollars, right? Millions of dollars, and this is year. So that would be 7 over 2, so $3.5 million per year is our slope. That's our rate of change, how it's changing. So now we can use either point, doesn't matter. We can use this point, we can use this point, it does not make any difference. And we write our equation. So y equals, I'll just use the first one, 15, okay, plus 3.5 times x minus 2014. That was the first thing they asked to do, write an equation relating the two. And then predict the company's profit in 2017. So let's put that in. We put in 2017 in here. So that would be 15 plus 3.5 times 3. Okay, which would be 10.5. Okay. So 15 plus 10.5 is 25.5 million. Don't forget to put the $1 million in there. Okay. Good. And let's look at the next one. A book publisher has fixed costs of $65,000 and variable costs of $45 per copy of the book. Write an equation for the cost of producing X books. If the book is sold for $60, how many copies does the company have to sell in order to break even? Okay, now this gives us different information. This does not give us 2 points. It doesn't give us 2 points. It tells us that it's fixed costs of $65,000 and variable costs of $45 per copy of the book. Okay, this right here is our hint. Per copy. As soon as you see that per, that's a rate. It's dollars per copy. So that means our slope is $45 per copy. So on every single time they make a copy of this book, they have to spend $45 for every time they do that. Now then, it also says there's fixed costs, which means they have to pay that no matter how many books they print. Whether they print 100 books or 1,000 books or 10,000 books, they have to start out by paying $65,000. So that's what they pay before they print a single book. Even if they print 0 books, 0 books would cost $65,000. Okay. Well, that's a y-intercept, because remember, when x is 0, so that's b, is 65,000. So then y equals mx plus b, y equals 45x plus 65,000 would be our equation. Okay, that would be the equation. Now it says if the book's sold for $60, how many copies does the company have to sell in order to break even? Well, if the book is sold for $60, then the money made from X books would be $60 for every book, so 60X. We would make 60X dollars. So if we're going to break even, that means we're not going to make money, but we're also not going to lose money. So we're going to make $0. So if our money made, the cost for X books is our equation 45X plus 65,000. So if we take that no money we made minus what it cost us to make it, our break-even point, that would have to equal 0. So a little bit of math here. This would be 15x minus 65,000 equals 0. So add 65,000 to both sides and divide by 15. So x would be 65,000 divided by 15, which would be, well, it goes in there 4 times with 5 left over. It goes in there 3 times with 5 left over. 3 times with 5 left over. Okay, so, and then we could keep going like that. So we'd have to sell. We have to sell more than that. We have to sell about that to break even. So we'd have to say the company would have to sell 433 1/3 books to break even. Of course, they can't sell 1/3 of a book, so actually they either if they sell less than 430, if they sell 433 or less, they're going to lose money. If they sell 434 or more, they're going to make money. Good.